This is basically example 2 on page 218. I've modified the directions a little bit so that we could practice more skills. I want us to find the points of inflection in the intervals on which the function f of x equals cosine x is concave up or concave down, not across the whole real line, just on this interval from 0 to 2 pi. I like this example because we can kind of know what the graph of cosine looks like, and we should already be able to know what the answer is, where the function is concave up and concave down, and where the points of inflection are, because we know what the graph of cosine looks like. So essentially, I'm going to pop the graph of cosine up real quick. Cosine is 1 at x equal at 0 radians. It's 0 at pi over 2 radians. It's -1 at pi radians, back up to 0 at 3 pi over 2 radians, and back up to 1 at 2 pi radians. It's the big nose, or the smile, or the upside down snow cone, however you remember what cosine looks like. All right, so to find the points of inflection, well, I'm gonna superimpose our last sheet here. A test for points of inflection are if the second derivative is 0 or doesn't exist, and the second derivative changes signs on either side of x equals c, then f has a point of inflection. We're going to need the second derivative. So knowing how to test for inflection points tells me what to do. All right, so to get the second derivative, the only way I know to do that is to go through what the first derivative is, and the derivative of cosine is negative sine of x. And the second derivative there is keep the negative sign and then differentiate sine of x. The derivative of sine is cosine. So that's the second derivative. Now we want to find the points of inflection in intervals on which the function is concave up or concave down. We can accomplish these two things at one time. So essentially, if I find where that in this interval, or if I'm interested on the whole real line, in the interval from 0 to 2 pi, I want to find where this second derivative is equal to 0, and where it's equal to 0 or doesn't exist, I'm going to look on either side of that to see if it changes sign, secant sign. So remember that cosine of x is equal to 0. I mean, you can kind of look at your graph for reference at odd multiples of pi over 2. So it's at x equals pi over 2 and 3 pi over 2. And if we were interested in figuring this problem out for the whole real line and not just for the interval from 0 to 2 pi, it'd be at all multiples of all odd multiples of pi over 2. We're just interested in the interval from 0 to 2 pi, so these are the only two in the interval from 0 to 2 pi. Now, let's, you can do kind of like a sign chart. Let's check. And I'm just going to sort of imagine, I'm checking this SIGN sign, the sign of f double prime in these two intervals. I need to extend to 2 pi, I guess. This probably is not to scale. All right, so I pick an I've got that my sign or my value of f double prime, the second derivative, is 0 at pi over 2. It's 0 at 3 pi over 2. So I just need to pick something in here, some value in there, to check the sign, SIGN sign of f double prime. So I'm evaluating this function. Okay, so I'm going to see, let's see, what's something in between 0 and pi over 2? That'd be pi over 4. So let's do negative cosine of pi over 4. And really, here, I don't care numerically what it is, though we could say that this piece is root 2 over 2 and it's negative. So that's less than 0. Don't really care how big. Now let's pick something in between here. The obvious thing to pick in this interval between pi over 2 and 3 pi over 2 is pi, and negative cosine of pi is let's see, that's negative, and then cosine of pi is -1, so that's going to be +1, which is greater than 0. So this one is negative. This one so far is positive. And now we're going to do, pick something in here. How about, excuse me, 7 pi over 4. That would do it. This is 6 pi over 4, 7 pi over 4, 8 pi over 4. So I usually think in terms of denominators to figure that out. So now I'm doing negative cosine of 7 pi over 4, and I'm trying not to reach for a calculator, but if you need to reach for a calculator, just reach for it and evaluate it. Negative cosine of 7 pi over 4 is something that is negative. Less than 0, so negative. Cosine of 7 pi over 4, and the reason I'm not reaching for a calculator is I'm thinking unit circle. I know 7 pi over 4 is over here. Cosine is positive in quadrant 4 because it's the first coordinate on the unit circle. And so this guy right here is a positive number, and then I hit it with a negative sign. So I've got my points where my second derivative is equal to 0 at pi over 2 and at 3 pi over 2 or for my x coordinates, and then I've got concavity changes. So on this interval, my function is concave down. On this interval, my function is concave up. This interval, it's concave down. And I know that from the previous page that when the sign of the second derivative is positive, my function is concave up. When the sign of my second derivative is negative, my function is concave down. And where those concavities change, I have a point of inflection. So to summarize, and I'm going to have to move this up a little bit, or maybe move the camera just a little bit. To summarize, F is concave up on the interval from pi over 2 to 3 pi over 2. And concave down on the interval from 0 to pi over 2 and 3 pi over 2 to 2 pi. Also, the point with first coordinate pi over 2 and the point with first coordinate 3 pi over 2 are points of inflection. So how do I tell what that second coordinate is? Well, now I'm talking about a point of inflection being a point on the graph, right? Here is where I've changed from being concave down to concave up. Here is another change where I've changed from concave up to concave down. These two are the points of inflection, and these are on the graph of F. So to figure out that second coordinate, I don't go to that second derivative or the first derivative. I'm going back to the expression for F. I've got to figure out what is cosine of pi over 2. It's 0. What is cosine of 3 pi over, 2? It's back to 0. So those are our points of inflection.